All right, morning everybody, and my name is Mark Denny. I'm a product manager within the wireless networking business unit at Cisco, and I'm responsible for the 3000 series product lines.
Hi, I'm Brian Levin. I'm also a product manager with the wireless business unit at Cisco, but I'm responsible for the 2000 series access points.
So one of the things that we wanted to talk about today was we just announced last week our next generation 3000 and 2000 series access points. So we've got a couple here for everybody to have a look at. This is our 3800, so 3802i, just brand new announced, and Greg Durai, our Vice President of Marketing, had it up on his session with Jeff Reed yesterday. We've got an integrated antenna model and an external antenna model that we can pass around for everybody to have a look at. Okay, want to have a little bit of a workout? Then we'll provide it, folks here. Let's have a look. There you go.
So that's actually a 2800.
Oh, right. Sorry. Yeah, thanks.
So we've announced both the 3800 and the 2800 as part of the next generation Wave 2 product line from Cisco.
Right. And so what Brian was just saying, the first thing is that they're both 11AC Wave 2, which is kind of a natural migration as all the technology's been evolving, next generation wireless speeds and feeds. And second and third generation of products for 11AC Wave 2 that we've introduced about 6 months ago. We came out with the 1850, 1830 series product line. And we're going to continue to roll all of our product lines this way to 11AC Wave 2. Now, the really interesting thing with these products is that we focused a lot more beyond 11AC Wave 2. So 11AC Wave 2 is kind of a natural migration, some really interesting technology. However, we thought there's a number of other things our customers are dealing with. For instance, the significant move to 5 gigahertz from a client perspective, or the ability of networking at 5 gigahertz versus just traditionally a lot more on 2.4. So typical access points, and including these ones, provide support for both 2.4 wireless and 5 gig wireless concurrently. But we're seeing a significant shift over the last couple of years to 5 gig, certainly with more channels for users to connect to and APs to provision, higher speed throughput certainly at closer ranges, handling a lot more high density type scenarios. So one of the things we've done with these access points is now we allow customers to decide how they want one of the radios to actually operate. So you've got your traditional 2.4 and 5 gig mode of operation, or you can actually have one of the radios act as a second 5 gigahertz radio. So now you can have dual 5 gig actually supported on whether it's an internal antenna model or the external model of the access point. To us, that's a really exciting feature and capability, and a number of our customers have been waiting for that type of capability for quite a while.
Yeah, so just because the introduction, you guys were talking about, I guess, Gigabit Wireless or Gigabit over the air. Right. So this is kind of the introduction to allowing you to do gigabit speeds over the air. Not the introduction, because that first came out as part of 802.11ac Wave 1, but this kind of takes it to the next level. This allows you to walk into a classroom, walk into enterprise, walk into a retail, wherever you go, connect wirelessly. As you look around the room, none of your devices have Ethernet ports on them at all, right? So it's expected that you sit down at your desk, open up your laptop, put your cell phone down, connect your cell phone, and have wireless connectivity as you would historically with wired. You have that same gigabit speeds. You can connect to video services, voice services, roam. It's very common for me to sit at my desk on a typical day, join a Jabber call, a WebEx call, which has both video and voice.
Yep.
Connect on the call, start talking. As I'm talking, decide I need to get a cup of coffee from the break room. While I'm talking, walk with my laptop, still maintaining the connection, still presenting, grab the cup of coffee, which is across the building, and then go to a meeting room. So it's roaming from access point to access point, having that real life, complete experience where everything stays connected, everything works well, everything just works.
Right. I mean, You're just working. You don't have to think about the network. You don't have to worry about the speed. The experience is all the same. It's a high speed experience. What we're also seeing a lot of customers today are increasingly as more and more devices per user are connecting to the network, like Brian was saying, often, certainly from our case and what we're hearing a lot of our customers across every market that we service, whether it's education, finance, healthcare, that you've got at least 2 or 3 devices concurrently associated with a network on a per user basis. In the universities, it can be much higher than that, depending on the student population and what they're really doing. So now you've got a lot of customers connecting, and some of them passively, but some of them actively. But still, it's all connected to the network. Sorry, go ahead.
So how is it going to deal with location tracking? How is it going to deal the AP with location tracking? Like the 3700s, which have the high-low around it. So how is it going to deal the AP with?
So for the location, you're talking about the whole location. Yeah. So these products are just announced, and we're going to be doing a couple different things this way. So one of the things that some of which we're already talking about. Some of it will be down the road, but we've got a second antenna connector here on the physical antenna product. So typically you see, the traditional 4 ports for connecting either dipoles or a cabled antenna to the access point. We've added a second physical antenna connector to this access point. So now we've got a number of different scenarios that you're going to be able to achieve with these types of products, whether it's a 2800 or a 3800. You're going to be able to connect, first of all, 2 sets of antennas to this access point. So when you go around this venue and you have a look at the ceiling or a number of different ceilings, often if you're in a convention center, anywhere typically where you see a high ceilinged environment, you're going to typically see at least an external antenna type product. In this case, we've got a number of customers who want to connect 2. Now for location, you'll be able to connect location antennas to the side of this access point to get that type of experience. So one of the things we're able to do, because of the architecture that we've implemented, where we've moved away from a 2.4 only radio, as I touched on very quickly before, we've now got this notion of a flexible radio assignment and architecture, where that single radio can now be software configured between 2.4, 5 gigahertz, or wireless security monitoring at FCS. When we ship this product in early May, those will be the 3 options, and then you'll see other options come down the pipe, like some location functionality and other services. So you'll have the ability of taking that radio and really deciding how you want it to be used within your network. And how does that work to our customer base? Well, today our customer base often is doing things like turning off 2.4 radios, where they have a lot of 2.4 noise. Not every AP needs to have 2.4, especially as the cell sizes are shrinking down to enhance the opportunity for connectivity. They're preparing for higher density number of clients. They're dealing with that today, so that cell sizes are coming down. From a European perspective, for instance, it's not uncommon to be talking about 170 square meters of coverage for an access point, down to 140 square meters for an access point. A couple of years ago, 3-4 years ago, that would have been significantly larger. In the United States, that translates to roughly 1,800 square feet, 1,500 square feet. We've got people that are talking about 1,000 square feet and sub 1,000 in some very, very specific cases. And as those cell sizes shrink, people are turning off more and more 2.4. So now instead of having that radio idle, we're going to allow customers can use that same AP and go 2.4 and 5, dual 5, sprinkle in some monitoring. Down the road, they'll be able to sprinkle in some location as well, and then other types of functionality. So really, really flexible, very excited about that. And our customers it's been going over really well with our customers.
Can you just take a step back and explain to us why it's important to go to 5 gigahertz?
Yeah, that's okay, sure. That's a big one.
Should we have that as part of design? Well, why don't we go through the product, give kind of a digital data sheet, and then we can get to some of the design considerations that we really address with this product and some of the key functionality.
That's a great idea.
So this is our new 3800 access point. So with the 3800, there's a lot of key functionality that comes with this access point. First of all, 802.11ac Wave 2. 802.11ac Wave 2 is key in the industry for a couple facts. One is just the data rates. The data rates hit that over gigabit Ethernet speed. So it's the speed, but then also it's a couple key features such as multi-user MIMO. Historically, what an access point does is this access point has 3 spatial streams in it, right? So if your MacBook Pro talks to this access point, it uses all 3 spatial streams. So I maximize the throughput that comes across the access point. But if your smartphone talks to the access point, it only connects with 1 spatial stream. So essentially it's wasting 2 other spatial streams. So with multi-user MIMO, what we do is we use kind of beamforming. So we can simultaneously transmit to 3 separate devices. So we have a 1 spatial stream smartphone here, 1 spatial stream smartphone here, 1 spatial stream smartphone here, all simultaneously transmitting. So you really take advantage of the airtime a lot more effectively, and you pass a lot more traffic. In addition, we're also introducing 160 megahertz channels. So wider channels, more throughput. So that allows for 2.6 gigabits per radio. And like Mark was saying, there's two radios that can operate at 5 gigahertz. So that means this access point right here can transmit 5.2 gigabits of data over the air. And that's just an insane number. That's twice to 3 times anything else on the market today.
Yeah. And I think the important part there is really about a lot of what we're going to be talking about, you'll see from these access points, is about versatility. It's about forward thinking in the sense where customers can deploy it today and then change its behavior tomorrow and adapt it as their networks grow and adapt to the network. As Brian was saying, 160 megahertz wide on both radios. That's really going to be spectrum dependent. Obviously, in different parts of the world, there's more or less 5 gigahertz. To your part of your discussion on 5 gigahertz, it's certainly a big discussion, and that we see that as more of a future type of opportunity and potential for customers to kind of grow into. We do have features that will recognize 160, aside from being able to assign 160. If there's enough air in the room, for instance, we have a feature that will dynamically allocate a radio to the channel. It'll determine the best channel width. And it could allocate a 160 channel if it determined that within the confines of its surroundings, that it was actually sufficient channel utilization and spectrum to be able to allocate a 160 wide channel. So we've built in a lot of that intelligence into the product. Now, what we expect people to be doing is likely to be looking at things like dual 5 gig running at 80 megahertz wide channels, or mixing 80, 160, 40 and 40, 40 and 80. They'll have all that level of flexibility. And then just to jump specifically to your question as well, the 5 gigahertz is interesting for a couple of reasons. First of all, there's a lot more channels. Now, a lot more is all relative to where you are in the world. In ITSE, in Europe, and in the United States with the FCC, there's a lot of bandwidth available relative to a lot of different countries. So you have a variety of different channels across what they refer to as uni bands, so Uni 1, 2, Uni 2 extended, and 3, which covers a whole range of the 5 gigahertz spectrum. And it's increasing in the United States and in ITSE. They're allocating more 5 gigahertz right now and over the next coming years. And a lot of other countries in the world have been proactively adding more channels. Not as much as Europe and the United States, but they've been adding significant amounts of traffic. Like for instance, China, Brazil, Australia, New Zealand, Hong Kong, Singapore, almost every country is really looking at what they can do to add more channels. So you've got more channels to play with. You can have wider channels allocated in those spaces you can handle. You can offer more potential throughput, and you've got more in a designed deployment scenario. For instance, in 2.4, you have 11 or up to 13 or 14 channels, depending on where you are in the world. But typically it's 11 that's really in play for most people, and only 3 of those are non-overlapping, for instance. So you run into a scenario where channel planning becomes really careful without impacting each other. And then at 5 gigahertz, you've got a lot more channels to play with when it comes to that type of channel planning and allocation.
One question you mentioned, you can produce up to 5.2 gigabits throughput. How is it with a wired uplink connection? I have seen only one port. Is this an 1 gigabit port, or
no, that's a great question. That's a great question.
Great question. Perfect segue.
I'll get through the whole data sheet, and then so this with the 3800. What's very unique about this is, of course, what you just spoke of, and that's the wired Ethernet, right? So there's a MGig port on this device capable up to 5 gigabits. Okay. There's also a secondary Ethernet port, which is labeled aux on this, and that allows you to do the 2 gigabit lag. So you can do 1 gigabit lag as well. Yeah. So depending on your switching architecture, it's very flexible. You have that one wire, you get 5 gigabits off of it. You have 2 cable pulls, you can lag them together and get 2 gigabits.
Now, even with what we're seeing a lot of too with customers with cabling, typically you really got to split. People that only pull 1 cable and people that pull 2, but they really don't want to connect that second cable. It's really just there in case something happens. And they would have the option of using both, but that means they have to connect both of them back to the switch on the other end. And they really don't want to have to do that, chew up more real estate. So that's where the MGig port, the multi-gigabit port, Ethernet port comes in handy to Brian and what Brian was saying. The ability of running up to 5 gigs, so they can do 1, 2.5, or 5 gig over single, pull all the power over that as well. You can use traditional Cat5e, which is brand new. So traditionally Cat5e caps at 1 gig. Now with Cat5e, you'll be able to go up to 5 gig with this connector. It's standards based in the sense that it's M-base-T organization that's also part of the standard for the IEEE working group that's defining this technology and taking it to open standard. So really exciting on that part as well. And then for customers who are in a position not to be able to use multi-gig right away, they could lag both ports together if they wanted to at roughly 2 gig.
And from a power consuming perspective, how much power does this access point need?
Yeah, that's a great question, and it falls in the AT category. So 802.3 AT is what we have both of the access points, the 28 and 3800 position for.
Right.
The 3800 also has a couple key features here. One main is the module slot for future modules that can be plugged directly into this. So this allows you to future-proof and expand your network.
Right. Right. And so for instance, today with the 37 and 3600, we've offered a few different modules. We first introduced 11AC Wave 1 on the 3600 via module slot, and we were first to market with that. We've come out since then with a monitoring capability and also the hyperlocation functionality that was raised before, and then the small cell technology, which is getting closer to getting through carrier approval. And that's a really interesting technology. And we're going to be looking at a couple different options for the 3800 that are kind of in the discussion phases for future releases as well.
Is it just an AP or also a controller inside?
That is another great question.
That's a great question, yeah.
And so, as you know, we announced Mobility Express on our 1830, 1850 product line.
Yeah.
The goal is to continue that across our complete 802.11ac Wave 2 portfolio. At FCS, it's coming as a post-FCS feature shortly after FCS.
Right.
So you would be able to run a controller on this access point as well.
Right. Yeah. So customers will have maximum flexibility. They can run through the controller, or they can run the Mobility Express capability. They can go either way, and they can move back and forth maybe they start with Mobility Express and move to controller, or vice versa.
Yeah,
that's
option. The whole goal of the Mobility Express architecture, right? You start with a small deployment, 5 APs, all the way up to 25 APs. You have your access point acting as a controller. As your network grows, as your needs grow, you install a larger scaled controller and add more access points. Those access points that were previously controllers fall back into just lightweight access points and act as a typical access point would.
Yeah.
So it's complete flexibility as your network expands or even goes in the opposite direction.
Yeah.
It just
Running with code 8.0?
this is of course, every single new release comes with a new code base, right? So there will be a new code base dedicated based off our 8.2 train of access points.
Right.
So it's just, we're adding more and more features to these access points, and every new release comes with new software.
Yeah. Did you have a question? Oh, okay. Great. Yeah. So lots of functionality. So like as we were talking about up front, that it's 11AC Wave 2, but it's much more than that, right? So we've talked about multi-gigabit on the 3800s. You have that option up to 5 gig. That's exciting. The flexible radio capability, where you can software define or configure the radio behavior of now not just a 2.4 radio. Personally, I think that for all of our customers, that's probably the number one feature for a lot of our customers of this access point.
Yeah, and we'll walk through some workflow.
Yeah.
We'll walk through some workflows and some use cases of that a little bit later in this discussion.
Yeah, we call out Dual 5 as one of the ones that a lot of people are really interested in. It falls into this behavior that Brian's going to go through, because I think it's the one that's got most attention from people. But our plan, like I was saying earlier, is to really provide a lot of options that customers can really decide either manually or let the network dynamically configure the role of that radio, such that it'll figure out in the network exactly what behavior that radio should actually operate in. And making sure, with the underlying premise to be able to provide really good 2.4 coverage, but not waste radios for 2.4, then make use of the just 5 gig or monitoring capability on that part. Sorry, I know you wanted to talk about some other stuff.
No.
Okay, so we've got that. The other thing we've built in to both the products is we've allocated a whole set of cores, hardware for hardware acceleration of functionality. So we've always been really aggressive on trying to maintain hardware-based processing. So we've implemented some dedicated cores for applications like AVC, so Application Visibility Control from Cisco. When it runs in certain modes of operation in your network, so you may be connected to a controller, but you're running Flex Connect mode. So you have a control plane connection to the controller, but your data is being switched or routed natively out of the access point. When you run AVC in that mode of operation today, there's a minor hit on the AP. With this new cores, there'll be zero impact on the access point's processor itself. It'll all be accelerated through dedicated hardware. We'll also be putting the tunneling capabilities, the CapWAP tunneling, encryption, decryption through that, and the plan is to just keep using that hardware for additional applications and features as we see fit. Go ahead.
So all of the AVC functionality is all the analytics is going to be done on the access point, and if it loses, CapWAP to a controller, it's in Flex Connect. Those analytics are still functioning. AVC.
Yeah, absolutely. So that was one of the features that we announced or released in one of our previous software releases, and that's where AVC stats are stored on the access point, where the access point is actually doing the AVC classification, and that is one of the key features that we're offloading as part of this access point. So that's being done in a dedicated hardware accelerator.
Yeah.
Our whole focus of these access points is to kind of handle all of the concurrent users and give them best overall experience. This is why we custom build the hardware that goes into this product. Right? This is why we put a lot of Cisco IP specifically into this product to make it work better than anything else off the shelf. Yeah. And this is what's always differentiated our 2K and 3K product lines from the rest of the APs in the market.
Right.
And so one of the key things that we really focus on with all of our development, all of our system tests, all of our real world testing is simultaneous video streaming users and simultaneous traffic mixes of what people would do in the real world environment. So it's great to say in your data sheet that you support X number of clients, but it's really what those clients do in your network that really matters, right? So if we have an access point in a room and half of you guys cannot connect to the internet, half of you guys get poor quality streaming video, it doesn't matter that we support all of those clients. It's just a bad overall experience.
Right. So one of the things we started a couple of years ago was we got away from doing single client rate at range, drag strip type testing, so-called. That's pure marketing. What we started focusing on was real testing. So TCP-based data testing, real clients. Now we're up to 100 concurrent clients in our test bed where we have 30 on 2.4, 70 on 5 gig. We publish our own reports. We have external companies verify the same type of testing on their own. And then we pump data traffic for a variety of different types, voice and video. And the voice and video, the key part there is that we keep pushing until we hit a MOS score that we feel is not really good enough, like about a 3.8 out of 4. And that's where we determine exactly the level that we're going to. So we run this primarily for ourselves. We will put it, competitively in there as well to see where we stand. But typically, we're really, frankly, focused on what we can do with our products. So we're pushing ourselves harder than, frankly, the market is and the competition, and we're focused purely for our customers at that point. So that's something that we're going to continue to push on. So today we're at 100. We'd love to get up to 150, even 200. Really push the limits. We don't have a customer today running 200 concurrent active sessions on the radio. You may have 200 associations, but concurrent users pumping traffic through the access point. But we've got customers that are definitely broaching 100 in certain circumstances, and typically people are certainly well north of 50 on certainly in a lot of parts of their network. And it's going to fluctuate like a lot of networks based on time of day, location, gathering points, large meeting rooms, depending on the market you're in. Higher ed's an easy one because their classrooms are typically very big anyway, so you've got lots of traffic going on through classes. But we're definitely seeing an increase in the number of users concurrent on every AP going up, and that's really a big focus of ours.
Can you just quick walk us through about the security capabilities that you have here implemented?
Sure.
So when you refer to security, you mean, of course, we're compliant with all the 802.11 standards, so we provide great over-the-air security on all of our access points.
Do you have any additional features that you provide here? Something like, let's say, packet filtering or sensors or anything additional to the, let's say, normal wireless security?
Yeah, so one of the things might be like .1x supplicant on the access point, so you can do fast authentication today with .1x at the edge switch. So that's one aspect you can do already with the access points. The other thing I would say would be using the AVC or that type of functionality. We can do some, some basic rudimentary, not basic, but because we can filter at what's going on, we can do some things about, permit, deny type stuff from that perspective. We also have a WIPS function that you can enable in the product, so you can proactively, from an network attack perspective, you can enable that type of functionality, and that will continuously scan on 2, 4, and 5 for people trying to access your network and attack it, and then either report it and or take action immediately, remediation. So a lot of different functionality that we try to layer into that type of thing.
I have a couple of questions about your the two 5 gigahertz radios. So you turn
Sure.
both of those on. How do you keep them from stepping on each other?
One of the things we've done, and Brian definitely can jump in, too, as well, that so both of the access points are designed, meaning the integrated model and then the external models are designed to manage that in a couple different ways. With the integrated model of the access point, we've got 2 sets of physical antennas built into the access point. So they're polarized horizontally and vertically to create some separation, physical separation, so that when you're running a traditional 2.4 and 5 gig, both those radios use a single antenna in a dual band mode like we've done traditionally over the last few releases. And when you go in a dual 5, each radio gets its own dedicated antenna. And then, so we've got the polarization to create a separation. The next step with the integrated and the external would be that we're going to mandate separation on the channel itself up to 100 megahertz so that we can have so both radios are actively serving off the 5 gig spectrum. And then we're going to mandate 100 megahertz separation just to create some additional separation there. And then on the integrated, we've got what we call a micro and a macro cell architecture, so that you still got a very similar pattern that you may have with the 3700 for coverage today with the 3800 and 28 like the 27. You're going to have one radio that's very focused on the micro cell, so a smaller cell. We're going to control the power. It's very focused coming down, and then the other radio will have an overlay cell that comes around that, so you have full coverage within the actual area of coverage on the access point.
What's the difference in the transmit power between the macro cell and the micro cell?
To get into the details of the dual 5, I guess let's walk through some use cases later. Let's go through
Okay, sure.
Yeah, I just kind of want, because it gets choppy when you jump into it. So I just wanted to kind of finish with the access point, all of the key hardware features, and then we can really get in depth with your question.
Can you tell something about the power of Ethernet?
Yeah.
Yeah. So it's
Go ahead.
completely 802.3 AT compliant. So it supports. So PoE in comes into the primary port and powers the device.
Yeah. So with the 3800, you can pull up the UPoE, so universal PoE from Cisco as well. And with future modules on the 3800, you'll be in the UPoE range. So day one with no modules, or even later on with no modules, both the 38 and the 28 will run on .3 AT. And we're in the final stages of qualifying the actual power consumption, but it's, for now we're just telling people to budget with the full 25.5 for now, if they need to do power budgeting.
In addition, this has a USB port for additional expandability. So that USB port allows you, in addition to having a module slot, to adding other devices to this. We're thinking of certain use cases such as BLE beacons or 3G, 4G type.
Right. A variety of different things that we've looked at. I mean, some of it, the Bluetooth aspects are probably the easiest one for most people to think of immediately. So we're just looking at a number of different things. It gives us a lot of flexibility. It could be GPS, like for instance. Some ideas are, you put in a GPS USB radio and you use it as a mechanism for identifying where the access point is, using it as a mapping key, all sorts of different interesting things we can do at that point.
Location tracking, right?
That's another element with the Bluetooth discussion. So, we do extensive Wi-Fi locationing today. Bluetooth is definitely coming into the picture for sure. As part of the hyperlocation solution also adds Bluetooth to that mix as well. So that's definitely something that, we'd be looking at as well.
Are you able to toggle that on and off? Like if you didn't want the USB port to be?
Yes. Yep.
Just turn it off in the software?
Yep. And it's, that gives you the option as well to manage your power draw.
So there are lots of questions about flexible radio assignment. And kind of the key feature that we really like about this product and is really industry revolutionary and will really change the way that this product is used in the industry. So by default, 2 radios in the access point, right? So it comes up in 5 gigahertz to that 4 gigahertz mode. So it serves clients in both areas. Typical deployment, say you're covering this room, you have 3 access points, right? So there's 20 people in this room. 1 access point has enough coverage to cover this room. So in the low density environment, we will give some channel diversity. So we'll have two of the access points serving in the 2.4 channel serving mode, right? As the density changes, as more people come into the room, that radio detects, or the access point detects that there's more people coming in through our radio resource management algorithm, and we adjust accordingly. So we see, okay, density is increasing, let's change our radio architecture. So on the fly, the radio changes from 2.4 gigahertz serving mode to 5 gigahertz serving mode. That allows for the increased capacity. So now you have more spectrum and more free spectrum in the 5 gigahertz band to allow you to have more users on your network.
Right. And the interesting thing there is that not only will it detect and change dynamically if you wanted to, you've got the option of doing it manually as well, but it'll also determine the appropriate channel bandwidth to actually allocate for that radio. So it'll do all that for you. You don't have to worry about that up front. If for whatever reason 80 is best in this space, it'll allocate 80. If 40 is best, it'll allocate 40. And then, like I was saying earlier, if it was able to allocate 160, it'll allocate 160. So it'll do it all for you.
We can place it in high density, high capacity environment.
Absolutely.
Absolutely.
Yeah, that's the goal of the access point.
The 3700 and the 2700 today are 1A and 1B in the marketplace for scale and performance for high density today. And these two will take it to the next level. Absolutely.
Yeah, and that absolutely. The whole point is to dynamically change.
Yeah.
In addition to just ubiquitous coverage, this also provides a security functionality into it. So if there's enough density that you don't need to provide that coverage, if there's every channel is covered, you have ample capacity for your users, then we convert that radio into what we call wireless security monitoring mode. And so what that does is that simultaneously scans both the 2.4 and 5 gigahertz band for WIPS attackers, rogue interferers, clean air interference, and just gives you an overall view of what your RF architecture looks like. So all this is happening dynamically in the access point. In addition, Mark Candace, and as part of the radio resource management, we've introduced dynamic bandwidth selection, or DBS. And what that does is that picks the best channel width for every environment. So in a high density environment, such as this, right? Lots of access points very close together. We say, okay, we want to maximize, make sure everyone has a clean channel. So we drop down to 40 or maybe even 20 megahertz channels in these areas to give more channels available. But as we get more isolated, a meeting room that has enough wall separation to make sure the RF is clean, we scale that up to the 160 megahertz channels.
Right.
So in the same network, on the same controller, in the same RF environment, you have access points operating in 20, 40, 80, and 160 megahertz. And that's completely dynamic. If the RF conditions change, your access points change too. Right. If more capacity, your access points change modes. Right. So it's a very, very, very dynamic environment.
Right. Exactly.
And so we've even, Mark kind of hit on this a little bit earlier with the micro and macro cell. So one of the key things about the internal antenna version, is deployed by many of our customers just because it's a smaller form factor and you don't have to actually attach antennas to it, right? So it's a lot simpler of an installation for a lot of our customer base. And so for most Omni type antenna patterns, we recommend to install the antenna version, the internal antenna version. And what it does really neat is it has this concept called macro and microcell. So since there's two AL211 AC Wave 2 radios in this access point, what we do is we focus one on a microcell, a smaller cell that allows the clients connected to it that connect at just the AC Wave 2 rates. So your all AL211 AC Wave 2 clients, or even Wave 1 clients, you can connect at the higher MCS rates, giving you that multi-gigabit connection speeds. We push you onto the microcell, so you connect, have a good experience. All of the other clients, the legacy A clients, N clients, AC clients that are far away from the access point itself, that are connecting at the lower data rates, that are just hogging your spectrum, that are making your performance on your access point as a whole degrade, they are all forced to the macro cell. So you have a larger cell that encompasses all the poor performing clients. You have a focused cell in the middle that connects all of your very well performing clients. So it just increases your overall capacity over the access point. So it's better overall throughput, better overall experience.
What is the average? How many clients can the AP serve?
Each radio serves 200 clients, and we test all the way up to that 200 limit. So that's 400 clients per access point.
Yeah, I think though that like we were talking about earlier, it's that conversation is more than just what can each radio serve, right? Like Brian was saying, there's plenty of marketing numbers out there that can look at 400 to an AP, 200 per radio. And this is why we were talking about before that we've started very much focusing on what we term as real multi-client testing. So a lot of our customers are moving towards 100. They're not at 100. Some of our customers definitely are at 100 in certain parts of their network, or special events that they may have, like a meeting, a big conference for the meeting, or a seminar, or something they're giving. And that's why we're really testing. So that's definitely the trend. It's trending towards 100 concurrent, and that's really what we're building from a hardware and a software perspective to be able to have capacity to maximum throughput of 100 or more concurrent devices actively using the access point. And then doing it split between 2.4 and 5 gig, because we know that you're going to have potentially BGN, ABG, AN, wave 1 and wave 2. All at the same time, right, on that part.
Did I understand you correctly when you said that it would automatically turn off the 2.4 and turn on 5 gigahertz?
Absolutely. And then even automatically switch from that to the wireless security monitoring functionality. So it's all, our radio resource management algorithm takes care of all of that dynamically. It sniffs the environment, it's listening to the environment, and it knows how the RF environment looks to it. It knows both Wi-Fi interference, but also non-Wi-Fi interference using our clean air chipset. So it knows everything that's going on in its environment and just makes the best decisions based on the information it has. And it's not unique to channel, it's unique to channel width as well. So for example, channel 36, Uni 1 channel, that's a 20 megahertz channel. So it sees what 36 looks like from a 20, 40, 80, and even 160 megahertz environment. So all the information is constantly tracked, constantly known by the access point. So the best decision is always made.
Yeah. So now, and you have the choice to turn that on or off. So customers can really manage it. If they're comfortable with the network doing all that for them, they can turn it on and it'll do it. Or they can manually do it.
From an RF design perspective, your
Right.
2.4 cells, if you put those, you're going to be spaced a little further apart than your 5. And if it's switching between 2 and 5, then you're changing your RF design. I just think it would be a little bit complicated.
Nope.
I don't know that you want to do that particular.
Right.
automated.
Well, I think so. That's one of the reasons that it's optional to turn it on. But we do think that getting towards that, that's the whole goal of radio resource management, is to help customers to really help them manage that aspect of the network. I mean, what we do find is a lot of customers aren't at the level of wanting to be able to deal with the changing environment every day and what's really going on. And the key that Brian also touched on was that the network itself can adapt real time. So you may have these, a lot of discussions depending on the markets where the flash mob scenario, where, I've got these hordes of people coming into certain parts of my network, morning, midday, so lunch, starting work, ending work, and that affects those type of planning decisions. So, and the other goal of the logic as well, would be that, it's geared towards ensuring really good, robust 2.4 coverage and 5 gig coverage for that time that the network's allocated on that part.
And I kind of want to hit on your point a little bit too, because the point that you're making is that the 2.4 radio generally travels 6 dB further than the 5 gigahertz radio.
Yeah.
So when we do high density deployments, such as pretty much any enterprise, pretty much any deployment in the world these days is what we consider high density deployment, just because the number of users connected.
Yeah.
So generally in the high density deployment, you don't deploy for coverage or for capacity, or sorry, I'm saying this wrong. You don't deploy for coverage, you deploy for capacity. So you don't want the radio to transmit the highest transmit power and cover the largest area, because you want the most number of clients on it. So if you were to do something with a directional antenna, or just, you can always crank up the transmit power on these, or RM will crank up the transmit power if you have them at a pretty far spacing, and that allows them to cover more area. But typically, they're closer together, and it's lower transmit powers, and it's more for the capacity, for getting more users on the network, and that's the goal of most of our, or pretty much all of our customer base. But so now I have the external antenna version too as well. So this is a little bit different of an architecture. There's the 4 antennas on the top that will be connected for your 2, 4, and 5 gigahertz radios. But we also have a smart antenna connector. I had to look for it. This smart antenna connector allows you to connect an additional 5 gigahertz radio to it, or 5 gigahertz antenna to it. So now you have 2 5 gigahertz antennas on the same access point.
Can I use it outdoor?
No, this is meant for indoor usage. Yes.
Well, outdoor. So the 3800 has a P version, a professional install, that a lot of people use. It's still an indoor AP, but in a NEMA enclosure, you can use it outdoor like that. And the interesting thing here with to get dual 5 running on an external antenna for 38 or 28, you need to connect 2 sets of cabled antennas to it. But we have a number of people that are definitely interested in that type of design. Like for instance, here in the convention center, if you look around in a number of areas, there's a combination of different types of patch directional antennas installed. And we've got a number of people interested on attaching 2 of those to these models of access points. Right. Or we've got a high gain 13 dBi antenna that's used. It's often referred to as a stadium antenna because it's used extensively in convention and arenas and stadiums. It provides a 30-degree, very tight cell coverage, and people are looking at connecting 2 of those guys. So yeah, you could certainly, the P version, for instance, in the United States, the FCC, we have to certify it specifically for US use in that environment based on the rule sets for use in an outdoor environment. So prior to the recent changes, you couldn't use Uni 1 outside, but now you can. We had to also, not in Europe. So these are all the things we allocate for on that P version that we can, so that you can use it outdoors. And in fact, like for instance, in the States again, it's the only indoor AP you can use outdoors. If you use the E, you're in violation of the FCC on that part. So.
Yeah, so Mark kind of hit on the key point. So with the external antenna version, typically what you would do is use directional antennas pointing in a specific area. If you look at the showroom floor here for density, you see access points hanging from the ceiling with directional antennas pointing straight down to maximize the coverage, right? So with these access points, you would have one set of antennas coming directly from the RT and CP connectors, and then you'll have one set coming directly from here. Right. So essentially you have 2 5 gigahertz access points built into one. So when you're designing a network, you can put one antenna in one direction, one antenna in a different direction. You can have them both pointing straight down. Right. Depending on your coverage, you can just have endless flexibility. Right. And unlike the internal, where we do a micro macro cell, the external does the same transmit power on both with goals of maximizing your overall coverage area. So it's very, very flexible, very smart. Just takes care of all of the configurations for you. You don't have to worry about anything. The access point has the RF intelligence to make great decisions.
Right, so we use this connector came from where's that connector? So we actually borrowed that right from our hyperlocation solution that we created this connector from. So it allowed us to have a real sleek design instead of having another 4 RPTNCs on the top or on the side. It looked horrific. We did model that and it just didn't look very nice. So we're going to have a cable that will go smart antenna connector to RPTNC, and then you just connect it to either more cables or directly into the antenna of your choice. The other thing that we've got a lot of customers that traditionally have done some design around band-specific antennas. So a specific 2.4 antenna and a specific 5 gig antenna, that's another option they can do with this setup. Likewise, in the future, we're going to have additional antennas for locationing and other features, functionality that will be able to connect directly into this smart antenna connector as well. So tremendous amount of radio flexibility and then even as much flexibility on the antennas. So that was, like I said a number of times already, that was a real big key design element up front for us on this thing. Wave 2, but way more than just Wave 2 on that part. And it's worth noting that when we're running dual 5, obviously they're both Wave 2 radios, so they're both multi-user MIMO capable concurrently. So they've got their own set of 4x4, 3 up to 160 on both radios, supporting up to 3 concurrent multi-user MIMO clients per radio on that part as well. Okay.
One additional question to the outdoor thing. How hot will they run? To which specifications, if you are in a very warm environment, right. What can the AP survive from a temperature perspective?
Yeah, so indoor is 0 to 40, and outdoor is, I want to say the external, is neg 20 to 50 or 55. I can't remember exactly on the Celsius part. I think it's 50, neg 20 to 50 Celsius.
Very robust temperature operating range for your environment.
So pretty common, and it should be the same as what we had on our prior access points, if I recall correctly. Yeah. And then, of course, the outdoor that are built for outdoor, have wider temp range. And then the wind chill, all the other types of the wind vibration and what have you, they're built for that as well. Sure.
There's a significant number of advancements in this, in the 3800 and 2800 series access points. For a customer that has a large Cisco wireless infrastructure already, are there any challenges with introducing these access points into your environment?
Yeah, there's absolutely no challenge of introducing this because the radio is same transmit power, same kind of operating footprint as our existing access points. Right. So you introduce the 802.11ac Wave 2 access point in a legacy ABG network, just more capacity to users that connect to the 802.11ac Wave 2 access point. Other than that, everything else works together. Access points support the same standards. They roam using the standards-based roaming. We make sure clients operate from access point to access point very, very well. So when you're introducing to a brownfield environment, there's no risks of introducing new access points. Of course, if you're doing a greenfield, we always recommend that you deploy like access points and same architecture throughout the area.
Do you lose out on any other feature set as far as any of the dynamic capabilities, or is that's all handled by the controller and the access points, regardless of which version?
Yeah, it's all part of the controller and access point. So, for example, dual 5 gigahertz mode looks like 2 access points to legacy access point that doesn't support it. So it's like 2 access points are in the same location on different channels. So that's all taken into the algorithm. If it's operating in the security mode, it looks like a monitor mode access point, and so it just gives you additional visibility. So the legacy access points aren't affected by its behavior; they're only enhanced.
The only thing I wanted to add was, depending on the age of the network that's deployed, an existing customer migrating, let's say, from much older devices, they're likely to be in a position where they probably want to do a site survey, because they're probably going to want to realign to a smaller square footprint for high density coverage. That's probably the one discussion that we see that most customers are really needing to look at. And that's where we're working with folks like Ekahau and other people to incorporate all the new functionality.
There's also an issue though with the 1242s and some of the older keys that can't go to the code that these are supported on, because they don't go to H.
Yeah,
right,
and in that case,
versioning is always
and that's always a managing thing. And in that case, certainly they would likely deploy a parallel controller. They're probably already looking at a newer controller, and then doing that type of migration as well. Yeah.